Is your online? Are you able to hear me?
Yes, sir.
Okay. Very good. So those who are online, am I audible?
Yes, sir.
So listen. Did you all make notes? So, right. Okay. I'll check it tomorrow morning. Tomorrow it's not done, you need not. Yes. Sanjay, what about you? You didn't upload your notes. When did you send? What time? Okay. So, what were the concepts that I asked you to write? So, I asked you to write the concept of capacitance, right? So, what are the capacitance of a parallel plate capacitor? C is equal to epsilon naught A divided by D. Then, see, if the capacitor is filled with a dielectric of thickness T, if the capacitor is filled with a dielectric of thickness T and the dielectric constant being K, okay, then what is going to be the value of mu capacitance? It will be epsilon naught A divided by B minus T plus T by K. Not necessary. D taniya illa. Yeah, that can be C naught. Okay, you can call it as C. Just say it as C naught. So C naught is equal to epsilon naught A divided by D. C dash will be equal to epsilon naught A divided by D minus T plus T by K. This and all I think I derived it in the class, right? Then, see, if you have multiple dielectrics which are present, then what will be the new capacitance? C dash will be equal to epsilon naught A divided by D minus T1 plus T1 by K1 minus T2. You have this formula? Plus T2 by K2. It keeps on going like this. Right? It keeps on going like this. When you have multiple dielectrics which are present between the plates of thickness, how much? T1, T2, so on till Tn. So what will be the last number? Minus Tn plus Tn divided by Kn. right? So this is how it is going to be, right? Next, you would have seen the concept of, now the next point is, what if the gap between the capacitor is completely filled with dielectric? What if the gap between the capacitor is completely filled with dielectric? See, if it is completely filled with dielectric, T will be equal to D. Am I right? So when you take this value and substitute it here, you will get C dash is equal to epsilon naught A divided by D minus, in the place of T, you will substitute a D. So D minus D will get cancelled. So you'll be left with D by K. This K will go to the numerator. It becomes K times epsilon naught A divided by D. And this epsilon naught A divided by D is what is going to be C naught. So it will be K times C naught. Clear? So it will be K times C naught. So what will happen to the capacitance here? Initially, the capacitance was C naught. After you completely insert a dielectric, its capacitance will increase by a factor of K times. Right? It becomes K times C naught, which is a very high value. Are you clear with this? Right. Then we have the concept of capacitors in series and parallel. So when you talk about series, what comes to your mind? Charge is same, potential difference is different, and how will the potential difference be? The total potential difference supplied by the battery will be equal to V1 plus V2 plus so on till Vn. Am I right? Similarly, what about parallel? Q is, so Q is different. The charge will get added. Right? What will happen to it? It will be Q1 plus Q2 plus so on till Qn. And what about the potential difference? It will be the same. So what about the equivalent capacitance of capacitors in series? So you will get 1 by Cs will be equal to 1 divided by C1 plus 1 by C2 plus so on till 1 divided by Cn. What about parallel? Cp will be equal to C1 plus C2 plus so on till Cn. Am I clear with this? Right. So how did we derive this? How did we derive this? By using this one, V is equal to V1 plus V2 plus so on. So in the place of V1, what will you write? Q is equal to CV. You will write Q1 by C1 or Q by C1, Q by C2, Q by C3. Like that you will write. Left side you will write Q by CS. So Q will get cancelled and you will get this. For this one, so you'll write C1V plus C2V plus so on till CNV. Correct. Right. Now we'll do a problem based on this concept. Did we do that problem from the textbook? Example problem. So we did that also. Then what is that we left out? Then what is the only thing that was left out from this chapter? Energy stored in a capacitor. So, okay, energy stored in a capacitor, right? So I think that derivation also would have copied it. Okay. So it's better you learn it. Anyways, that derivation is not a part of your syllabus. But if you know that, right, you will be able to understand the concept of inductor in the 6th chapter. Okay, so it's better you know it. So what is energy stored in a capacitor? See, derivation I'm not teaching you because it's already there. So you will get the energy to be equal to half CV square, but C can be written as Q by V. So you write half Q by V into V square. V and V will get cancelled. So which is QV by 2, or you will get Q square by 2C also. So this is all about the energy stored in the capacitor. What about energy density? So you will get half epsilon naught into E square. How did we derive this? You will get it using the formula half CV square divided by volume. So what did we use for volume? Volume is area of cross section multiplied with the distance of separation. So this will be equal to half into C is epsilon naught A divided by D multiplied with V is E into D the whole square, the whole divided by A into D. A and A will get cancelled. One D is lost from here and the other D is lost from here. So what is that you're left out with? Half epsilon naught is. That's it. You're clear with this? So this is the formula for energy density. So instead of it being an air medium or a vacuum, had it been something else, mostly it will not be vacuum, had it been air medium, instead of air medium, had it been something else, then what will epsilon naught be replaced with? Just now we saw what will happen to the capacitance. It will get increased by a factor of K. So here what should you replace with? You will write K times epsilon naught. See, mostly they will not ask that kind of a question. Okay. So whenever they ask about energy density, by default it is half epsilon naught E square only. Suppose they want to twist it. Okay. And they replace air medium with something else. Then what are we supposed to do? Epsilon naught should be replaced with K times epsilon naught. That's it. Clear with that? Right. So we'll solve some problems. But before that, I'll give you a table which you need to make a note of. So write down physical quantities, right? Physical quantities. This is with battery. Okay, 1 minute. See, this concept is not a part of your textbook. Physical quantities, initial values. So next one is with dielectric, where you say battery connected and battery disconnected. Okay, so write down this part. So if I talk about capacitance, so if I say the initial capacitance is C naught, right? Now, if you insert a dielectric, the capacitance will become K times C naught, and here also the capacitance will become K times C naught. Are you able to understand? Similarly, the next point is about charge. So if I take the initial charge to be Q naught, this will be equal to C naught into V naught. Okay. Now, if I take the initial potential difference to be V naught, listen to this carefully. So here it is Q naught into C naught. Q naught is equal to C naught into V naught, right? This V naught is there, no? See, what I'm going to do here is, when you insert a dielectric and still keep the battery connected, the potential drop will be V naught, because you're keeping the battery connected. Whereas if you disconnect the battery, it will become V naught divided by K. There is a point to be remembered. Meaning I have a capacitor. To that capacitor, I kept the battery connected and I inserted a dielectric. Then the potential drop across the plates of the capacitor will still be V naught. If I disconnect the battery, but dielectric is there inside, the potential would be not V naught anymore, rather it will become V naught by K. Okay. Now what you need to do is, this is there, no. The new charge, this will be equal to the new capacitance. When a dielectric is there, what is the new capacitance? K times C naught. And what is the new potential? It is V naught. So it will be K times C naught into V naught. Meaning, if the initial charge was Q naught, when you insert the dielectric and keep the battery connected, its charge will increase by a factor of K. Whereas, if you multiply here, what is the new capacitance? K times C naught into what is the new potential drop? V naught divided by K. So K and K will get cancelled. What is that you are getting? So its charge will be V naught. Sorry, Q naught. Under what scenario? When you insert a dielectric and disconnect a battery. Are you able to understand here? Right. So this is the potential difference. The next concept is about electric field. If I take the electric field to be E naught, right, this E naught will be equal to V naught divided by D. So what will be the new electric field? The new electric field will be V naught by D. What will the new electric field here be? V naught by K into D, meaning the electric field will decrease by a factor of K. Okay. Next is energy. So when I talk about energy, if I say U naught, it is going to be half C naught V naught square. So half C naught V naught square. What will be the new energy when the battery is connected? Half Kc naught into V naught square. So what is happening to the energy? It is increasing by a factor of 8. Whereas when the battery is disconnected, half into Kc naught so C naught V naught square by 2K. So it will decrease by a factor of K times. It will decrease by a factor of K. This concept is not there in textbook, so please make a note of it. It is very rare that you can find problems based on this. Okay. Done with this? So open your textbooks, go to exercise problems. So how many problems have we completed? First 3 are over, right? So if you finish 5, 6, and 7, no? Now go to the 8th one. Oh, you're writing it? Okay. First one, first in the chapter concept. So look at 2 point. Look at 2.8. Read the question. One minute. So 2.8. For a parallel plate capacitor which is having air between the plates has an area of cross section of 6 into 10 power of -3. Okay, meter square. So distance between the plates is 3 millimeters. So 3 into 10 power -3 meter. Okay. So potential difference is 100 volt. What will be the? So Q is equal to how much? Okay, listen to this carefully. What is the capacitance? It is going to be epsilon naught A divided by D. So what is the value of epsilon naught? It is 8.85 into 10 power -12 into A is how much? 6 into 10 power -3 divided by what is the distance of separation? 3 into 10 power -3. So 3 will cancel this 2 times. This and this are gone. So answer will be approximately 17 into 10 power -12 farad. So unit of capacitance is farad. So you will have 17 picofarad. So that is going to be the capacitance in this scenario. Am I clear with this? Now, if this is the value of capacitance and this is the potential difference that you have connected, then what will be the value of charge that is stored? Q will be equal to CV. So Q is equal to what is the value of C? 17 into 10 power -12 into V is 100. So answer will be 17 into 10 power -10 coulomb. That will be the answer. Clear with this?
Yes, sir.
Yes. It is going to be 17 into 10 power -10 coulomb. So that will be the charge on each plate of the capacitor. Clear with this? Go to the next one. 2.9. Okay. So initially it was air, right? And what was the distance of separation between them? It was 3 millimeter. Now what are they saying? If you take a mica sheet and you insert it between the plates of the capacitor, and the mica sheet has a dielectric constant of 6. Dielectric constant is dimensionless and it doesn't have any unit also. It's a ratio of the same physical quantity, right? So if that's the case, then what is going to be the new capacitance? C dash will be equal to how much? 6 times C naught. That's it. Why? Because when you insert a dielectric between the plates, when you completely insert a dielectric between the plates, the capacitance will increase by a factor of dielectric constant. So 6 into, you know what is the value of previous? So how much is this? 102? So it becomes 102 picofarad. Am I clear with this? Right. Next. How much is the capacitance? 12 picofarad. Two subdivisions. So what is the second part? After the supplies, okay, what will happen to the capacitance? It still be the same. That's what I gave in the table. No? Whether you have battery connected or disconnected, its capacitance is still the same. But what will happen to the potential drop? Potential drop will decrease. So capacitance is still going to be 1 or 2 picofarad. But what will happen to the new potential? It will become initial value by 6. What was the initial value? Potential will decrease by this factor. What will happen to the charge? It will be initial capacitance into initial potential drop. So what was the initial charge? Initial charge we calculated in the previous case, no, 17 into 10 power. So it will remain the same. Check the answer at the back. So let's see what are all the points they are expecting. 2.8, no? 2.9. Did they mention about capacitance? What did they mention? They've no. So that's what they're expecting. What will happen to the new parameters? That I've already given you a table itself. The value will not be 1 or 2, it will be something else, no? Because I didn't take 8.85. I took 8.5 into 1 or 8. Don't look at the values, but concept is clear, no? $17.7, that's what they told, 18 something. So 17.7 into 6 will get. 17.7 18 eduthukoda. 18 into 6 108. 108. 48 10 4 carrying. Okay. Yeah. So the capacitance here is 12 picofarad. Then, sorry, battery is 50 volt. You need to calculate energy, a simplest problem. So half CV square, half into 12 into 10 power minus 12 into 50 square is 2500. So this cancels the 6 times. So 6 into 25 into 10 power minus 10. So 6 into 25 is 150. So 150 into 10 power minus 10. Or you can write 15 nanojoule. So you'll have 15 into 10 power minus 9 joule. You will have 15 nanojoule. Here. Okay, next one. .11. 11th problem. Tell me. Okay. So go to the example problem. Last example. You find something like a 900 picofarad capacitor. You have a question like that. I'll do that. This 11th problem you are supposed to. Okay. So those are online, listen. What is the page number for this problem? 82. So page number 82 problem. Okay. So 10th example problem. Okay. Listen to this carefully. Read the question. I'll tell you the concept here. So what are they saying? A 900 picofarad is initially charged using a 100-volt battery. Let's visualize the situation. Okay. 900 picofarad is charged using a 100-volt battery. Okay. If this is a scenario, then what is the energy that is going to get stored in it? It's going to be half CV square. So half into C is how much? 900 into 10 power minus 12 into 100 square, which is going to be 10 power 4. So 1, 2 into 10 power 4, 10 power 6. So 10 power 6 into 10 power minus 12 is 10 power minus 6. So 1 by 2 is 0.5. So not 1 by 2, 9 by 2 is 4.5. So 4.5 into 10 power minus 6 joule, or you can write it as 4.5 microjoule. Both are same. I hope this point is clear. Okay, accepted. Now, what is the next part of the question? This is disconnected from the battery and is connected to another 900 picofarad capacitor, which is uncharged. Am I right? Now they are asking what will be the electrostatic potential energy of the system. System in the sense both the capacitors put together. You don't have textbook, huh? You don't have textbook? Then ring. Okay. But at least take it from someone, know how you understand the question. You also don't have a. You have a. So this 900 picofarad capacitor is disconnected from the battery. So how is the situation going to be? You have this 900 picofarad which is charged. Now what are you doing? You're connecting it to a you're connecting it to a capacitor which is uncharged. Right? Now, what will happen? You tell me this is plus, this is minus. What will happen is the charge from here will start flowing to this. Am I right? So when the charge from here is flowing, when will it stop? When will it stop? After? There is no distance here. Both have the same. Both have same charge, right? Wrong. It will not stop when they have the same charge. They have the same potential. Because if I take an object, see, for example, if I take this remote, if I keep it here, nothing is happening to it. If I bend my hand like this, it is falling down. Why? Because there is a potential difference, right? This height is more compared to this. So it starts moving from higher to lower potential. Same is the case with charge. Imagine waterfall. It flows from higher to lower potential, right? Same is the case with charge. It will flow from higher to lower potential. This does not have any charge, so no potential. So once this starts getting discharged, this will start getting charged. So there will be a point where the potential drop across both will be the same. At that point, this kind of a transfer will stop. So am I clear with this? So when will it stop? When they have the same potential. Okay. Now, if I take the potential of this battery to be V1, of this capacitor to be V1, here the potential is 0. Right. Now, what will happen is in the initial scenario, what is a charge here? Can I write Q1 is equal to C1 into V1? I'm going to derive an expression. Observe. Here, can I say Q2 is equal to C2 into V2? Okay, 0. So initial charge of the system is C1 V1 plus C2 V2. This should be equal to, when they attain the common potential, what will be the value of Q1 dash? It will become C1 into V, where V is the common potential. I told you, same potential. That V is the same potential. Here, what will be the charge? Q2 dash will be C2 into V. So initial charge of the system is C1 V1 plus C2 V2. Final charge of the system will be C1 V plus C2 V. If I take the V common out of it, then I'll have C1 plus C2 into V is C1 V1 plus C2 V2. Then what is the value of V? It is C1 V1 plus C2 V2, the whole divided by, and this is going to be the value of the common potential at which this transfer will stop. So in this problem, you need not do this much because fortunately both are 900. What if the question was, initially you used a 900 picofarad, you completely charged it, and you take this 900 and connect it across 700. At that point, you cannot say they will get equally divided. So then what you should do is 900 into 100 initial value plus 700 into 0 divided by 900 plus 700. That is how you need to do. So in this case, it's very simple. As I told you, you need not do this much. This concept is called as redistribution of charge. This is also not there in your textbook. Write it down. This concept is called redistribution of charge. Why are you doing tough work? How will you understand if you need to recall? After 6 months, you will forget. இதெல்லாம் நீட்ல வரும்டா. இந்த மாதிரி क्वेश्चंस தான் கேட்பாங்க. சீரியஸ்ல இருக்கு, அது எப்படி இருக்கும்? பேட்டரி இல்லையே. So last thing you can remember like a formula. Basically, if you look at that, no, C1 V1 plus C2 V2 is basically total charge. C1 plus C2 is total capacitance. So what is the formula for potential in terms of charge and capacitance? V is equal to Q by C, no, same thing. Clear with this? Okay. Total charge divided by total capacity. But Q net initial கண்டுபிடிக்கணும், how will you find? Yes. அது தெரியணும்ல, அதுக்காக தான் அப்படி எழுதுறேன். Mostly they will not directly give you the initial charge. எதுக்கு அந்த மாதிரி கொடுத்தேன்னா, initially they will give you only the values of capacitance and potential. Questionல டைரக்டா சார்ஜ் கொடுக்கவே மாட்டாங்க. If I directly give you Q1 and Q2, no, அந்த மாதிரி क्वेश्चனை பார்க்க மாட்டேன். So you will get confused how to apply. அதனால தான் அப்படி. Understood? So using this logic, substitute all the values and tell me what would be the common potential. So in this case, both are 900. Hari Raghav, solupa. Here, what will you substitute? Either C1 is C2. V1, V2. Okay. C1 evolo? 900. Here 900. V1, 100. So 900 into 100 varo. I'm not talking about picofarad. No? 900 into 100 plus C2 evolo. What is the next capacitor that is connected? Question level. It is connected to an uncharged capacitor of reading. Did you find uncharged capacitor of how much value? Same value. So here what will you have? 900. Initially, what was the potential drop across this one? 0. So 900 into 0. So you will have only 900 into 100 divided by, here what will you have? 900 plus 900, 1800. So what will the value be? So put it very simple, it will be 50. You need not solve it. By looking at it, you can say when they are of same nature, they are of same value, they will stop exactly when the potential falls to exactly half the value. That will be 50. So now the new potential on the first capacitor will be 50. The new potential on the second capacitor will also be 50. And this is going to be 900. This is going to be 900. Don't forget 900 is in terms of picofarad. So what is going to be the energy of the first one? Half. So how much is it? Half 900 into 10 power minus 12 into V square, which is 2500. Half into another 50 square, 2500. So basically, how much will you get? 25 into 9 is how much? 250 minus 25. You will get 225. So 225 divided by 2 is going to give you 12 point. So basically, this will be 225 by 2. This will be 225 by 2. So how much will you get the total value as? You will get 225. You know, they ask what is the total energy of the system. So this energy and this energy will get added. When you add them, right, the half and half will get cancelled. Half plus half is 1. So you are going to have 9 into, observe this. This is 10 power 2. This is 10 power 2. So how much is that? 10 power 4. 10 power 4 into 10 power minus 12. So you have 25 into 10 power minus 8. So that is going to be the total value. Right? 9 into 25 is, so how will you do it fast? See, nearest value to 9 is 10. 250 minus, so basically what is it? 25 into 9 is 10 minus 1. So 250 minus 25, it is 225. Right? So 225 into 10 power minus 8, that's the answer. Or it is 2.25 into 10 power minus 6. I don't know how the answer is given in the textbook. 2.25 into 10 power minus 6 joule or 2.25 microjoule. So what happens here is the energy exactly becomes half. See, this is 900. This is 900. Now, initially the potential on this was 100. Now, after you connected in that kind of a system, it became 50 and 50. So, this is C, this is V. What is the formula? Half CV square. Half into C, you put 900. V square is 50 square, this is 2500. This is idude energy. This is idude energy. Total energy add panna, you will get the answer. So, answer is 2.25 microjoule. Okay, but here the question is, initially the energy that was present on the first capacitor is 4.5 microjoule. Here it is 2.25. It became exactly half. So where did we lose the 50% of energy? We lost it in the form of heat because the charge was getting transferred through the wire. So during the process of redistribution, the energy is lost in the form of heat. And how much is the energy that is dissipated? 4.5 minus 2.25. Answer comes out to be 2.25. Am I clear with this? Okay. Now you are going to do the 12th problem of textbook from the exercise. 11th or 12th or whatever it is. 11th or okay. That 600 microfarad something. Do that. Here are my NCERT questions. Okay. We selected NCERT questions. Here are 600 is connected to 200 volt supply. Yeah. 17. Twelve or half? 12. 12 now. Yeah. So basically you will get half into half into 600 picofarad. Okay, 600 into half into 600 to 10 power minus 12. So 300 into 10 power minus 12 into V square is 4 into 10 power 4. So 3 into 4, 12. 12 into 10 power minus 6 over there. So it will be 6 microjoule. Correct? Huh? Got it? So first one is 6 into 10 power minus 6 joule. So after that they disconnected and did all those things. Sir. Okay. No, did they do the disconnecting thing? And that is okay. But after disconnected and all those things. Is a question having that it is disconnected and connected to a 600 picofarad capacitor? Do that part also, no? C1 into V1 square by 2, not C1 V1 the whole square. அது நீ வந்து பார்த்து எழுதணும் அப்படியே அதை ஃபுல்லா அந்த எக்ஸ்பிரஷன் போட்டு then you have to write பெரிய எக்ஸ்பிரஷன் வரும். That's not a part of your syllabus. என்ன அப்புறம் the derivation is not a part of CBS. இல்ல அப்படி பண்ண முடியாது. ஏன்னா half into You will have C1 plus C2 into V square here. Half into C1 plus C2 into V square. Half into 600. So 1200. So 10 power 4. So it's 10 power 6. So 6 into 10 power minus 6. This is what we get. So initially, what was energy? It was 12, no? 12 into 10 power minus 6 joule. Now it is 6 into 6. It's exactly like the previous one. The energy also fell to half the original value. But I hope you could understand. Those who are online, could you do it? Divya,
Yes, sir.
did you understand how to do?
Yes, sir.
Okay, next. Addition. Okay. So, I'll discuss more problems from this chapter. See, this chapter is over, but I'm not going to go to the next one. I'll do two things. How many of you want me to discuss the first test answer paper? So that I'll do. Secondly, I'll do some more problems from this chapter. Okay. So the Saturday, not this Saturday, the following Saturday, can we have a test in this chapter? 2 chapters officially we can close, so that during your holidays also you can work on your weak areas. Okay. So the week following it, we'll have a last test, and then we'll wind up for May month. We'll have 15 days holidays. But I'll give you some work also. Work on it. Like maybe not too much of load, but you'll have balance of both. Okay. So is there any other doubt? Did you all make like you all wrote down the notes? No. Those who didn't complete it, by tomorrow complete and come. Or else on a serious note, I'll not allow. Other, I understand you are on a leave, but make sure you complete it. Sanjay also. Completed, fully. எல்லாமே தெரியுமா? இல்ல புரிஞ்சு பண்ணியா இல்ல அவசர அவசரமா எழுதுங்க. புரிஞ்சதா? I don't want that also to happen. Don't do it for my sake. Okay. So next class will I'll give you few problems from previous year questions from this chapter. Okay, we'll do that tomorrow. And if you have any doubt, let me know. Sort of. Other doubts, Suma? So those who are online, you can wind up.
Okay, sir. Thank you, sir.
Yeah.